Communication is hard.
Yeah, it's almost like we were trying to carve out a spot.
The live stream is going to start at 7. Started around 7:15.
Should we move that thing or ourselves? Should we skip back to get it?
You have to scoot to there.
Yeah.
It's like a minute lag.
Yeah. I think we'd have to like just rotate the whole road out to here. Like basically to the edge. I think if we draw a line.
This works. We're looking at the live stream.
And the feed. Because earlier I was like, when I did it the first time, I was just like, real quick, I see the real results. This time I reran with all the details, so I'm kind of going through it.
Is it in Python? Machine learning steps when you see it?
Yeah, Python's really heavy. Mostly Python. But also someone was manipulating data, which Python's doing, but so is Excel.
I heard this is
the slides. Tell me about times I published the slides.
Oh yeah. Five minutes for my shows on there. Let's see, we have 15 minutes for what is intelligence, so one
Yeah.
or two, 15 minutes.
15.
Yeah.
Okay.
Three thought experiment, we did in the Etl Pipelines, 30 minutes. More thought experiment, 20 minutes.
30 minutes. 4 loops.
Yeah, that's 4 loops. Casual ML and AI design challenge, 20 minutes.
This is 30.
20.
20. There we go. Who's everybody?
We got the coordinates, I think,
The last address I was
living in BC like 5 years ago. I'm checking anything. Yeah, that's great.
How are we looking on the
Should speed up.
I think y'all gotta come back to basically. It's kind of the front edge of that thing is cut off. We can probably scoot down like a foot or two.
I asked the woman also at the front desk,
Should we put the board more in the window? 'Cause it's
but
kind
it's
of,
just what was written on the board, so I wrote stuff.
you wrote some stuff? It's good to have a group of designers.
Sorry, I think that's right.
General finding is like it's good to put something out to get a reaction rather than
I fight that constantly. I'm so bad about
How are you?
that.
Welcome back.
representation, like you're mixing up its understanding of what the concept is as much as like that two-dimensional image. It's so flippant weird. And what I like, I don't know, I like that as a design challenge because it's such a universal pattern. You just have you have a range of sliders, and like there's so many better ways to. So like, that's a good, just straightforward like classic design challenge.
Yeah.
Today we're kind of leaning more into like designing the data, you know?
Yeah.
Philosophical. But I like that as like another side of the same.
The numbers could definitely be bigger, and this.
And you can't even, it's all, I really played with it a bunch to figure out what was going on, and it's all ratios. So if you bring everything down by the same amount, the picture doesn't change.
Right.
So that, you can't even tell that by looking at it, you know? It's just, you don't even understand like what the image
You
is.
really have to like mess with the numbers in order to create like tangible.
This is a great example of like engineer design shit.
Yeah.
That's like blowing up in the world. And imagine how much more friendly and understood, like how much more understanding we have of AI if it were just designed well.
I'm finishing up a concept piece for my portfolio where I've basically taken a bunch of IoT like interfaces like thermostats, smart irrigation controllers, security systems, and redesigned the hardware interface as well as like some of the stuff for the apps and dashboards. I might start on the AI thing.
Oh, dude, that'd be cool. If you, yeah, we should talk about that. If you're gonna do like a conceptual experiment, we might get a real we kind of sync before you get into it. Like, might be something easily algorithmic that I could, you know, click onto and play with too.
So, okay, question. What do you know about how much or any experience you have with disaggregation algorithms?
Segregation algorithms?
Yeah.
Like classification stuff?
Like, you have an aggregate measure from like a meter reading, right? Like water or electricity, and then disaggregation based on assumptions of how appliance use energy, so or water. So you have your water bill, and then you use these algorithms to split down the appliance which is coming from your toilets, shower heads, stuff like that shit, right?
So you're like watching for the spikes and stuff like that in energy usage
Yeah,
and trying to
yeah.
decide.
So
like,
I know
this is all from the meter.
Yeah.
The only data you have is meter, right?
The only data you have is meter, and then you have some minor like data, like which you would basically call assumptions on, you know. So let's say a home was built in 1992, and you know that the toilets are, or let's 1995, because after the federal law went into effect, the toilets now in this house have to be 1.6 gallons of flush, right? And that's their very maximum amount. So like assumptions meaning like those types.
Yep, got you. Cool.
So it's easier to do with electricity. I don't know much about the algorithms. I know it's easier to do with electricity because they're the malfunctions that happen in electrical distribution are more apparent. If the grid goes down, it's fried, right? It's not providing electricity to that end source. Water is
binary.
Yeah, exactly, binary. It's either on or is water, there could be a leak in somebody's individual piping or like the water main or distribution.
Is this what you've been messing with? Just thinking about this?
So I've created an interface for it. It's in my portfolio actually. Yeah, it's called it IQ.
Gee, we should talk about this because
But yeah.
even as simple as like just discerning between like your background water usage and your like active water usage. So we can watch spikes, count how much the area of the spike, and then just count the baseline, and just differentiate like this is the likelihood of a leak of this magnitude in this like cluster of data. Something like that. Is that what you mean?
Essentially, yeah. So let me bring it up for you. So
They didn't make it easy.
It's okay. Right.
So like you go through your typical sign-up process. Sign in, so then you complete a sign-up process. We've got 3 bathrooms, we've got a dishwasher, so this shows your total water usage, right? So you can have a comparison to neighboring households within within a certain radius. And that could be, yeah, and that could be a back-end architecture position, or it could set maybe, I haven't really played with this, but it could be something the user sets if they want to see, okay, compare me to households and 5 versus 10 or something like that. But here, you go to switch, and you have a little fix. You can see how much shower, toilet, closet, outdoor irrigation, kitchen faucet, bathroom faucet, and even though they're both technically faucets, it's not something like so basically just like that. You can see how much
Yeah, but that's, time series data and doing analysis on time series data is that. I mean, I know no direct experience, but I've talked to a few people who are playing with that.
Yeah.
Know enough to get started, especially for like exploring design.
I would really love to,
What if there were like a game kind of thing where you can make like water teams or something?
Yeah.
And like you and your homies could all like put your data together, and you gotta like lower your water usage. Like we're gonna drop it by 1% or 5% or something like that. If it were all, I don't know, that might be too huge.
Gamification in that sense responds to highly called ideas.
Yeah,
Most of the people using this type of dashboard analytics, like homeowners, they're looking for savings opportunities, financials. They're saying, okay, and granted, there's going to be shit like a woman being like, oh, well, the shower was up in July, my husband was using the shower. Stuff like that.
Also, our chosen consumption isn't that significant. I mean, the waste is so much, like you're saying, leaks, background, like stuff that we don't know where it is.
Right.
Stuff that's not used.
Yeah, you don't have
Financial incentive always works.
Yeah.
It just works.
Gamification in that way, like, because it's financial, it feels so highly, like,
Yeah, you're right.
California property.
Yeah, you're right. Just do it.
It's not a bad idea. I just don't know how gamification,
No, probably not. It'd be a fun experiment, but I think, like, if you're talking about like markets, then certainly something that's just a straightforward cost-saving tool will always beat out a game.
And then I want to create something that's like connected to the utility. I mean, it requires a lot of like from the utilities, which some are happy to give, others are horribly like guarded about it. Bullshit cybersecurity. Oh yeah.
Don't mind me. Moving in your space.
Hi, everybody. Wonder if does this thing still work? The quiet bunny thing.
No, but you just gotta hold up 2 fingers. That's it. Yeah.
Cool. Well, hi everyone. We're gonna go ahead and get started. Thank you all for coming. My name is Adam.
I'm Raj.
This is Steve.
I'm Steve. I'm staying seated because of my foot.
Yeah. Thanks for coming. I'm gonna start with giving you a brief overview of what this meetup is and why this meetup is, and then we'll get into learning about all of the acronyms that go into artificial intelligence. There we go. And just a heads up, here at Capital Factory, they let us live stream. So that camera up there, it's pointing right now, and the frame is mostly just this, but it does capture some audio. If you're not comfortable with that, surprise, sorry. But the reason we're recording is for people that couldn't make it here today, and also for posterity we want to share with other chapters around the world. We are the Austin chapter of this global community of meetups, and it is made possible by a nonprofit based in San Francisco. Why speculative futures? Typically you hear those terms in the financial sector. They mean very different things in the financial sector than they mean in this context. Speculative comes from a discipline of design called speculative design or critical design. It was a term coined by a duo based in England and Austria named Anthony Dunn and Fiona Raby. This was in the 90s. He wrote a book called Hertzian Tales that was really, really interesting, and they are some very interesting thinkers. And then futures, thinking about disciplines, mostly academic disciplines of future studies or strategic foresight. It's ways of thinking about the future in a more strategic manner. It's not meant to be predictive. It is very much meant as a forecast and a planning tool to help us think about what could or could not be, what we like, what we definitely don't like, how we can go from where we are towards what we would like or not like.
And this is something that as designers we don't always have the opportunity to really work on or to really think about. So this space is sort of dedicated to explore some of those ideas.
And then we need chairs. We've got a few more chairs.
Oh, you're very kind.
Yeah.
Yep.
Okay, cool. So yeah, Design Futures Initiative, it's a nonprofit. Our mission is to bring people together to help imagine a better place to live. We'll be doing that in a sense today. It'll be very much focused on designers working with AI, machine learning, various types of technology, what might make our lives easier, what might an easier future for us be. We do that by, we're working to expand this global community of meetups. There are meetups on 5 continents now. There was, in 2018, there were 7 chapters. Now there's like 38 chapters, which is pretty exciting. And we're doing this to think about what are the implications of the choices that we're making today. Machine learning, AI, those are great examples of the decisions that we make today that are going to be amplifying effects of those decisions, so we should really think about them. And then to belabor this point, we're looking to bring together designers, strategists, artists, futurists, really anyone interested in these kinds of topics to think a little bit more broadly, a little bit larger scale, a little bit longer term about the ethical, political, societal, and economic impacts of the things that we are laboring to create and put into the world. So if you're interested in learning a little bit more about this, for Austin Design Week last year, I did a full workshop where I really dove into getting your feet wet with speculative design as something you can incorporate in your day-to-day design practice. I work as an interaction designer, and I do my best to take this, this way of thinking and the methods that inform that and applying it to the work that I do. This is also written on the board, and I'll show it again at the end if you're interested in continuing these kinds of conversations outside of this room.
Hi, I'm Stephen Wilkinson. I'm the founder and CEO of Second Brain AI. At Second Brain, we build intelligent language tools to improve human communication by letting people focus on what they mean to say rather than how they need to say it. So in 2018, we joined Techstars Startup Accelerator for their music program. We brought our team to LA, and we built a tool called rapgod.ai. It's an artificially intelligent lyric writing assistant, and we use that to prove our approach to language synthesis. Since then, we've focused our core efforts on Second Brain Bank, which is something we're going to be talking about a lot soon. And we've been working on taking the efforts that we put into generating language through lyrics and bringing that live online in a performance context. So we went to Dubai early in May for the AI Everything Summit, and we presented a lot of our work, did a live performance there. And this summer, we're working on adding an algorithmic member to a band, one of our favorite bands, and working in the studio with a couple of artists. So RapGod started as an experiment in 2016. If you want to go back one slide. Yeah, that's good. So I saw some people were doing some work with creative AI, writing scripts in 2016, and I thought that the way those algorithms were failing was really interesting. They were like outputting like really interesting short phrases, and then they'd kind of fall apart and go to gibberish. So I figured if we broke that down to lyrical content, that was something that would be more digestible and it would handle that better. And that ended up working out really well. I kind of set some time aside and locked myself in my room and just said I wasn't going to go to sleep until I made it work, like one of those kind of forcing functions. It was like my 6th time really trying to understand what neural nets were and how to apply them, and kind of clicked. Like something I've been trying to get into since the late 90s when I was in comp sci and kind of dipped in and out of, and now the world of machine learning and AI is becoming just much, much more accessible every day. Like the barrier to entry to this stuff is just crashing. So I took a bunch of lyrics. I took a bunch of Snoop lyrics because it's Snoop and it's really distinctive, so you can know if the thing's kind of working, right? And at the time he was doing Snoop Lion, so he was doing a bunch of weird stuff anyway. This like gave me like really good cover to send out strange lyrics to a bunch of friends. So the Turing test was kind of just send out these lyrics to a bunch of friends who are like hip hop heads and just see who could kind of fool into thinking that this was a new thing. Some of the people who I sent that stuff out to joined the team, and we kept building, and then we had some people come and go, and we're still building on that, that core premise. I was really originally drawn to this group by the idea that speculative design could be a way for us to really better understand the impact of the things that we build before we build them and actively build toward a better future for all humans. So, Rap God, it assists in your creative process and frees you from writer's block. You can see an example, it's been looping behind me, but you would write, oh, is this playing? Oh, those are animated, but they're not playing. Oh, that's fine. So anyway, normally this is just like a text editor here, and you would write the first line, which on this demo is home is where I sit on the couch and practice on my nap bod. And then if you hit rhyme, it gives you an inline, and it says something about Rap God there. Basically, you write out a bit of a phrase, and then whenever you run out of something, you hit the right button, and it'll complete your thought to the end of the line, whether you're in the middle of a line or you're on a fresh new line. That's the basic interaction method. What you write is sent to an algorithm that's been trained on rap lyrics. Then this next slide, there's a library of second brains that are trained on your favorite artists. There can be a second brain for yourself, for your many different selves, personas. The idea is as you kind of switch between contexts, switch between what you're working on, you can switch a brain with you, and it helps you to write like your best self, however you define that best self. All right. So that's kind of like just a quick overview of it. If anybody wants to dig into it, if you have an iOS device, you can hit beta.rapgod.ai and sign up for our beta program. And if you want to know any more about RapGod and stuff, I'd be happy to talk to you later.
Well, and in the interim, we do have a couple more chairs over here, and we can also grab a few more chairs. As people come in, we'll get cozy. We wanted to make this as communal and discursive as possible, so feel free to adjust the space to your liking. So before we dive into things, out of curiosity, how many people here identify or work as designers? A fair amount. How many people are on the more traditionally technical side, engineers, developers? Is anyone on the periphery of either or interested in either and working in something totally different?
My background is cognitive science.
Oh, cool.
I've been trying to get into cognitive computing related fields like data science. So.
Okay. Nice.
Cool. Happy you're here.
Yeah.
How many people are messing with machine learning, AI, data somewhat regularly? Cool. Awesome. Anybody completely confused as to what AI and machine learning is? It's totally fine.
We threw
All right,
a lot of
Somewhere in the
acronyms in the event title on purpose. XYZ is actually not a technology that I'm aware of.
Not yet.
Not yet. It might be after today.
Got to come up with
We'll have to come up with a
XYZ
good one,
means.
yeah.
It's the bonus exercise.
End goal today, define XYZ.
So it'll be super interesting to get your perspective on this first discussion. The way we're thinking of breaking out tonight, we're thinking we'll start with two kind of guided, facilitated discussions. It's very much meant to be an open discussion. We're just here to poke and prod at things. And then we'll move into things that are a little bit more of thought experiments. So thinking about, based on the discussions we have, how could we apply this as designers, or as designers in 5 years, and 10 years, and 15 years, and so on. So that we can dig into what is intelligence. So if you want to spend about a minute just thinking to yourself, when I say the word intelligence, what comes to mind? That is meant to be an intentionally broad question. And after about a minute, we're going to partner up into groups of 4, and we're going to discuss as groups and try to come to some consensus around what do we think intelligence is. We'll spend 2 or 3 minutes, maybe a little bit more, as a group discussing, coming to some kind of consensus, and then we're going to discuss as a group en masse what is intelligence. Does anyone have any questions? Thoughts? Cool. Perfect. All right, I'll do a timer on my phone, so when it beeps, we'll break into groups. If you want to kind of look around and see who could be in your group of 4 based on who's sitting by you or who who looks like someone you want to meet. Kind of just make eye contact with them, and then just be like, all right, cool, we're in a group. So in about 2 minutes, we'll break into, 1 minute, we'll break into groups.
Do you share over there?
I can introduce the next one.
I don't want you to jump in when we get to what is AI. I don't want you to jump in when we get to what is AI.
Roger introduce it, and then I'll let you kind of speak. Did I skip a little bit in the first, just like intelligence, do you have notes? Okay,
I left intelligence.
okay, because I meant it to be broad, because I'm curious to see if anyone comes to the same conclusion I had. Is intelligence like mental, brain? Is it gut? Is it existing?
Is it psychological? Is it chemical?
Is it emotional? Is it social? It'll be interesting to see how the group just defines intelligence.
But learning from repeated experience. That's very good.
That's what you think it is.
I mean, at this moment, I do.
I feel like it would have been good. Yeah. I feel like having done this, I feel like we're going to get to make him write down something. I don't want it to be too like design. I think he gets into it. So it's just like it's a discussion.
Yeah. People seem to be discussing.
I guess Greg, you gave us
I've been talking to him. Yeah.
I do. I have all those people. Here you go.
Yeah, I really like it.
Yeah, part of like I want to do like a how to do meetups guide for activities. Yeah, it's just so much helping people out. So you've got to get people, especially the designers, who like apply. People that make things like to apply what they're being told. And come to just work and then come to their own conclusions. That's perfect.
You should have brought the.
We still have it. We still have it. I wrote first lesson some Sharpies. Maybe we see how this discussion goes.
Is there anything we need most of this?
Already brought the.
And then I put the ability to
Yes, so I took this new job that's got me traveling to the asshole of America to work on site with Walmart UX designers. Yeah, it's the company itself is scattered, but this assignment is it's a very complex UX problem. It's really forcing me to focus my brain.
As shitty as they are to employees, they are like from an urban rural divide. They are in rural areas.
Yeah.
Like they employ people that they sell to.
Yeah.
And they're trying to spin up their own internal health.
And like for they have a really like variety of fast tracks for people who are working in the stores to then get involved with corporate operations.
Yeah, I'm gonna sell your scooter.
Okay. Are we gonna do some standing?
don't think we will.
Trade? I can stand back.
No, I don't think we'll utilize the market.
But yeah, Steven, so like I would love to work on some other
Oh yeah, get a little break from that.
yeah, it has and has some application of AI. I have a few I have a laundry list of ideas related to water and natural resource management that I'd love to run through sometime. Heading back to that, so I'll on Sunday, but if you're around Saturday,
Yeah, Saturday might be alright. Let's touch base tomorrow.
okay.
Or Friday rather.
Yeah.
Sorry, it's still
Yeah. If not, I'll be back in a couple of weeks.
We'll do something for sure, yeah. I got like real sick the past couple of days. If I'm feeling good Saturday.
Okay, yeah, for sure. I'll hit you up tomorrow.
How are y'all feeling? Do you need a few more minutes to come to some kind of group consensus?
Good, got something?
Yeah. We need
2 more minutes?
Okay.
No, 3 minutes.
3 minutes.
3.
My phone is
3 more minutes.
We typically learn round 2, which is fine.
Mine is the ability to synthesize
Oh yeah, I think we can get through some of that a lot.
into a cohesive something. I just got that one thing.
But that can apply
In some way, yes, they're synthesizing from multiple inputs. So how do we want to synthesize our I guess they want us to come up with consensus. Yes.
Yeah, I mean, yours seems like a good idea.
The ability to synthesize multiple inputs into a cohesive for your environment.
Yeah, pretty good.
I think it can. But we're talking about just like intelligence inherently, what is intelligence? Now we're putting it into context. So I think, so is the exercise right now to put it into context, or is it to just have a layer?
Maybe just
I just want to look up
just announcing a
the
project.
definition of the number 2.
You guys are thinking.
It's so indicative of our current.
perfect. So how are y'all feeling now? Have you come to a consensus of sorts? Yeah?
Got it? Yeah?
Yeah? Close enough?
Close enough?
Something where like the whole is.
So out of curiosity, I think it'd be interesting if we can go around the room and as concisely as you can, if a representative from each group will share what they came to a consensus around of what is intelligence. We can start with.
We came to the ability to synthesize data into a decision.
Into
A
what?
decision.
A decision.
Very decisive.
That was concise thinking.
Yeah, 5 words or less.
Well, one of the places we were getting stuck was between figuring out if people are intelligent, ants are intelligent, or plants are intelligent,
Or all of the above.
or all are above, what the level is. Because there's, you could go, we also talking about something a little bit more low level, like responding to your stimulus in your environment or something like that, but, is a plant really, a plant's not thinking, there's not any thoughts. So of course this stuff's not gonna go into what is artificial intelligence versus intelligence. But
Yeah, I think that's good in like, is there a scale of intelligence? And where does it start and end?
We really back and forth. We talked about adaptability, about the decision, the ability to make decisions that would run counter to what sort of the natural flow of events would be. So if you're hungry, for example, if you were a dog, you would sort of eat as soon as you found something that was like edible and seemed tasty. Whereas if you're a person, you can decide I'm going to hold off for X number of hours, or I'm only going to look for a certain type of food, and kind of delay that. And then there's about that kind of more functional approach of something that would take in inputs and enrichment spitting out some outputs.
Like that, like delayed gratification as a function of intelligence? That's cool.
We also talked about turning the environment to adaptability of the system to be able to respond to perturbation in the environment, as opposed to a mindless tit for tat. I hack you, you hack me. It's being able to introduce error, and someone is able to go, oh wow, I need to adapt.
Yeah, ours was kind of tethered to adaptation as well. It was basically about the ability to learn. So within any given system, there's like a set of rules and parameters and the way things operate. And artificial intelligence specifically seems designed to be able to kind of like you set the stage or the parameters, and then it kind of operates on its own, so it can learn new things and do new things. People the same way.
We came to the conclusion that, the consensus that intelligence is mostly around problem solving and learning based on interaction and knowledge of your environment built upon past experiences that can be put together to form new solutions. So something common to all life, but not non-living things.
But the main point is that they're inputs that feed into that decision making and that.
Yeah, and history.
Builds.
Yeah.
We kind of went around and talked about intelligence as being adaptability, about learning from mistakes, having it be iterative, problem solving, and we talk about building on the learning and having it be more complex, and then kind of like making the connections out of the complexities. I don't know if you can add to that.
Did you want to respond to their species intelligence?
Oh, yeah, I don't have to respond to that, but I was gonna say that I think that plants are intelligent.
What?
I agree.
Plants are intelligent,
Yeah.
just like how they grow and can respond to the environments they're in, but that's just me.
So is it still a part of that level of, that there are just different, very different kinds of intelligence?
Yeah.
And so, depending on, because nature especially, and we're part of that, it's really sophisticated, and each individual has its own, kind of intelligence.
Like that individual intelligence?
Oh, yeah, no, I'm just throwing it out there, but someone had brought up this to me outside of this group, the book, Programming the Universe,
Yeah.
that everything
simulation, that's for sure.
Okay. So, amalgamating everyone in my group's thoughts, we came up with self-guided learning, or the ability for self-guided learning. Wait, let me start again. Self-guided learning with the ability to synthesize multiple inputs into a cohesive something.
We don't have to go.
What?
Cheater.
Yeah, we are cheating.
Yeah.
I wrote learning from repeated experiments, and I did it live.
I also think of
Close to y'all.
about the function of intelligence as being about survival,
Yeah.
evolution. Like evolution is kind of a meta-intelligence because it's like optimizing for survival and mutations that will, better adapt to the environments.
Yeah, adaptation, layers, different forms of intelligence are interesting themes throughout a lot of what y'all were saying.
Cool. So now we'll do the same thing we just did, but now think about AI, machine learning, NLP, natural language processing. What do those all mean to you? Maybe think about again like application form. But yeah, if y'all, since y'all are sort of grouped up right now, if you want to just jump into a group discussion, go right ahead.
And prior to diving into those discussions too, since we have Stephen with us,
Do my little what is AI thing?
yeah, I thought it might be interesting for Stephen to give us his take on these things.
Oh yeah, cool. So a few notes here I'll go through. Wikipedia says, I feel like it's always good to go to the wiki. In computer science, artificial intelligence, sometimes called machine intelligence, we'll get into that a little bit more in a bit, is intelligence demonstrated by machines in contrast to the natural intelligence displayed by humans, which a lot of people got to like sort of human versus non-human, human versus animal, human versus machine. So intelligence demonstrated by machines rather than people. I like the definition that AI is what really smart computers are going to be able to do really soon. So if you go back to the 50s and read what people were talking about AI doing, we've accomplished a lot of those things. If you took today's autopilot systems and brought them back to a pilot from the 50s, like it'd be hard to argue that that wasn't artificial intelligence. That thing wasn't making intelligent decisions. But we look at those things today and we see them as like a list of steps that are pretty smart steps, but it's a computer running through steps. So a lot of this is, are we able to recognize intelligence that is non-human as equal with human? It's really easy if you know something's a computer to start like picking at it and kind of sussing it apart. But when you don't know, like are you fooled that it's intelligence, or when are you convinced that it's intelligent? I think there's a really interesting kind of fact around that one that I pulled from an Adobe article, and that's consumers use more AI than they realize. While only 33% of us think we're using AI-enabled technologies, 77% of us are. So that's some nice round, rough numbers, but I feel like that's pretty it's pretty ballpark with like my experience. I don't know how you guys feel about like what you run into and see out there, but we're in this stage right now where for a lot of different reasons, what is being done with AI, what's being done with deep learning is being largely hidden from us or is like progressively revealed to us. And we're kind of in this interesting area. So I think that's an interesting part of this, this discussion is, especially as designers, how do you know that what you're interacting with is AI, and like what kind of responsibility do we have?
Is anybody using Google or Facebook?
Yeah, I mean, dude.
A billion at least.
Yep, yeah, for sure. But I mean, I'm saying like parts of those systems even that you kind of expect to be a human. Like there's more and more of this where in this context we expect the other thing to be human, right? And then, you know, that when that falls and that's not a human, then like great chaos ensues. And I think, you know, Google calling people out restaurants and making reservations and stuff. I mean, this happened a little while back, but you know, that one was kind of enough of an uproar that it really, I mean, it caused Google to really pull back from that. It's kind of crazy how much they pulled back from their aggressive AI stance since then. So I think, you know, really thinking as designers, like how much responsibility do we have to let people know? How do we do that in a non-interruptive, non-intrusive way? So can we deliver the same kind of insight and intelligence that we want to, while also informing people that the thing is an AI? So I think that's a really interesting split. And I think that's probably We can get some practical examples afterwards.
Yeah.
Yeah.
I think, yeah, when he was thinking about our consensus around a communal interpretation of what is artificial intelligence, what is intelligence, what does it mean for a machine to be intelligent.
Mhm.
We, as human beings, we have a tendency to think about everything as if it were a human analog or if it was part of our world and subservient to us, but it's always really interesting to think about what are things that are not human, what makes them intelligent. So as you were saying, like plants, that's intelligence, it's just not intelligence as we understand it, so oftentimes we just dismiss it. And there's a whole philosophical school of thought around that, but I will not get into that. But as Stephen was saying, some examples that we all may or may not interact with every day. Spotify, I listen to the Discover Weekly playlist, and I'm pretty adamant about liking things or telling the algorithm I don't like things so that it recommends things I'm more likely to like. I've been getting really annoyed with reCAPTCHA and CAPTCHA because now it's asking me to do multiple rounds of telling the machine what is or isn't a thing. There is Google Translate. I got to go to Korea last year, could not speak a syllable of it, but I would type something into my phone and show it to people at restaurants and bars, and I was able to communicate with them that way. If you type emails on your phone or in Gmail, it'll suggest like sentence completion. Do you want to explain
Yeah,
that a little bit?
I threw that one up there. So there is this application used by Kansas City that allows the water and wastewater utilities to, based on past weather data, to sort of use AI to predict when there's going to be a sewer overflow and if that happens by what amount, so that they can deal with that before it even happens. So that factors in weather patterns, precipitation data, moisture conditions, as well as current repairs and state of the wastewater infrastructure. I'm an environmental scientist who sold out and went into tech, so this shit is fascinating to me, but it's probably not used by the average person on a regular basis.
And then we had a fun Mike Tyson inspired example of, no, there we go.
Deepfakes are fun, can be fun. But what? Oh.
So if you don't know deepfakes, deepfakes is it's an ensemble algorithm that tracks facial position and then will map somebody else's facial characteristics onto anybody, so puppet actors.
Someone applied this to a video that they superimposed Mark Zuckerberg's face onto someone that wasn't Mark Zuckerberg and shared a message that Mark Zuckerberg absolutely would not share, and then they sent that out on Facebook. And even with this, me and Steven were chatting, like, we were all sitting and looking at it and we're like, did a person do that? Did a machine do that? Like, was it a person who was just incredibly detail-oriented sitting and doing it?
How much of it's algorithm, how much of that is somebody editing? It's hard to tell right now when you look at it, but I mean, we're certainly there algorithmically where that kind of output is possible and much higher quality.
Oh, I got ahead of us.
That's good. Oh, we gotta go back to the exercise.
Surprise, no exercise. This is just chatting. And then the other acronym, ML, machine learning. I'll let the experts speak to that.
How many people are familiar with machine learning? Yep. So today, when people use the word AI, it's really often a buzzword or stand-in for machine learning. Machine learning is really just the ability for a computer to learn how to do something from a set of examples. So traditionally, we'd sit down and we'd write out a series of steps that tell the computer what to do. Now we combine an algorithm with the right kind of data, let it read that data enough times, and it slowly learns what to do, and then we stop it when it's good. So we have we kind of broke it down a bit into the algorithm as our first point here. So as designers, we're way on the practical side of AI, or like as it is for humans. You know, like looking at the application of AI to humans. It means we don't need to worry too much about the details of what the algorithms are, the jargon that surrounds like the actual implementation of the algorithms. I like thinking of algorithms as our new tools, like the tools that we can use, as like the building blocks for manipulating this world. What's most important to know is an algorithm is a set of instructions for a computer to follow. Algorithms in this, I mean, that's really too simplistic though for our case here. These algorithms are much more complicated than that. You can kind of black box algorithms and think of something that you can give them an input and they're going to give you a certain kind of input back. So sort of thinking about, we're going to feed data into this thing and then we're going to get something out of it from the data. That's our main lever. So black boxing the algorithms and not worrying too much about what's going on is a great way to quickly be effective in this field. It's really, really easy as you start reading and learning to get really just drugged down into algorithm design. That's where so much of the effort in machine learning and AI is today, because all the glories in publishing papers, there's way less people on the practical side, becoming more and more. So I suggest just kind of trying to like get decent at like at some of the embracing the jargon and letting the jargon go quickly. I guess as an example for Spotify built-in playlists, they send a list of your existing songs, like what you've been listening to, what you like, say a playlist you already have built. They'll send that list of existing songs to an algorithm that's looked at millions, billions of playlists. So the way that they'll train the thing is they know like a playlist, that's a known good playlist. We have lots of good playlists. We can take that playlist and we can remove several items from it. And then we train an algorithm on what we left, and then we check to see if the next thing it guessed is close, similar, or exactly, depending on our needs, to what we removed from that list. So we already know the answer, we withhold it from the computer, we get it to guess, and when it starts guessing really well, then we decide to let it go on real world data. If training goes well, if everything's done right, then the thing performs well on real world data. That's a difficult process, and more often than not, like, we get really weird, strange artifacts out of these things. Then a trained model. A trained model basically, it's what we get when we show the computer all these examples in an algorithm. So we take an algorithm, the algorithm analyzes a bunch of examples, algorithm outputs a model. Now we can take that model and the algorithm, and those together become the thing that we can feed something into and get something out. So a model of the world is just what it sounds like. It's an algorithm's understanding of the world, or the world as we've represented it to this algorithm. And then we're on compute engine. Yeah, so we need a computing engine. We need somewhere for this stuff to run. Most of this breakthrough comes from deep learning. That's another jargony word that's kind of under machine learning, but we don't have to worry about that one too much. So it just means this stuff's being run on GPUs. It's being run on hardware that's designed to do massive parallel computation. And like the kind of stuff that renders 3D worlds or that runs games. Now we're kind of co-opting all of that, that processing power that works well for simulating worlds.
So for the designer and me, when I think of cloud computing systems, you can think about data centers. So it's not you are at home, you have a giant box to have things operate on. You have 1,000 graphics processing cards. GPU is a graphics processing unit. Most Macs, my little one, the fan starts going because it has an okay one. Amazon has data centers all over the United States, probably all over the world. Google has data centers all over the United States, all over the world. So you are asking these services to start going through something, and it is distributing that to various locations and various machines.
Yeah, the main point here is that one of the big challenges with this is just it takes a lot of hardware to run a lot of this stuff. At the same time, we'll show some examples. Like, it's crazy what you can get done on a GPU that you might have in a laptop or at home.
I had a question. To go back to what you were saying earlier about black boxing, which I like, because honestly, we don't need to know exactly how things run. But I wonder for designers, what we really need to know is our assumptions.
Yes.
Right, so I think Spotify, and I don't know exactly how Spotify works, but the assumption is that you want something very similar to what you already like, and that you're very happy with something, by the same artist, in the same genre, with the same rhythm, with the same beat, with the same type of lyrics, which may not always be true. Right? So it's like, is our role as designers not to understand what's inside the box, but to understand people better, or to give them options for kind of how we feed them back information that we think is useful for them? Like, we have to determine what's useful, right? And I think, that was my question. It's not really a question, it's a comment.
Yeah.
About like the underlying assumptions. Like, we can assume that AI can do something, right? But Spotify has built-in assumptions as to what makes a good recommendation.
Right.
And it seems to me that's either a data science or a designer decision. I'm not sure
and
which.
that's where we have to close the gap, because it's kind of both.
It's not-
Both, yeah.
But one
Okay,
interesting
I'm like, are you flipping me off? What's happening?
That was meant to be both. Wrong finger.
You're talking essentially about which algorithm is chosen.
Not really, just like if, for instance, let's say you and I are gonna design a new music thing that's gonna be
Yeah.
slightly different from Spotify. So Spotify takes your Discover Weekly and you upvote, downvote, different things, and
Yeah.
then you put it in the black box, and you tell the black box to give you stuff that is similar to what you like. That's an assumption, right? What if I want something that's something I've never heard before, and how do you give the user, like how do we keep users from being in these bubbles of like. I'm gonna give you exactly what you've listened to before, and you'll never, come out of 90s hip hop ever, because I'll just keep feeding you 90s hip hop until you die.
I think of that, I'm saying that what you want to do is you don't want to find music that's similar to the music you like, but music that people who have similar musical tastes to you like. So for example, I like sea shanties, I like a lot of folk-related stuff. I like sea shanties, but I also like Zydeco, and those that people like. But people who like one of those things are probably going to be sort of folkies and probably like the other one too. And so I'd want a recommendation like that. But I might also have really narrow tastes and only like really traditional folk music, in which case I'd want, only like, Joan Baez, Pete Seeger, really the traditional stuff. So I want to sort of determine what's the range of tastes that people like me have, and then also what are in these tastes, and might not necessarily be stuff that even sounds much like the music that I like.
Yeah. And that seems to me like something that's very critical and happens outside of that black box.
Yep.
And I don't know if that happens with designers, with conversations, with marketing people, with product, or is it a data science? Right.
And I think
what I'm curious about AI is like, yeah, so we'll start dealing with AI, but as designers, how do we enter that conversation?
Yeah, and I think you're raising kind of the
What you
core.
have to do is pretty much understand the context of how the user is using the system.
Yeah.
So if you know this person, let's say you're designing a Spotify app, which I don't know if they're accepted anymore, but they're doing it on a run. It's going to be a lot different from when they're listening to music, driving a car or at night right before bedtime. And so as you build out your personas or what have you, you can talk about the types of activities that they're engaging in. And if you're able to somehow extract a data point from that, so let's say, okay, let's find out when they're running, and then we can feed that to the algorithm.
Up tempo, kind of similar, yeah.
So that's a really good point, that labeling data is kind of what you're talking about. Like if we are Spotify, right, and we have our app installed on all these phones, and we can turn on a feature where people subscribe to it or something, and we can get their location data. Now we can figure out when they're running. So we match that with what music they're choosing to play when they're running. We do that billions of times, and we have a really good idea of what people in general like to listen to when they run. And not just general people, we can get down to very, very specific taste clusters, where if you already like this music, you're gonna like this music when you run, and get really, really accurate with those predictions.
Or notice how fast you're running and
Yeah,
play you the music
totally,
that
yeah.
makes you run faster.
And your question too is a really, really good prompt for the group thought experiment that we'll dive into in 20, 30 minutes. But it's a really good prompt for thinking about what do we need to know.
And one more point on the point that you made. There's a recursive nature to all this that isn't immediately obvious when you get into it. And it's the self-learning aspect, the self-healing, and the self-improving aspect of all this, where you're kind of talking about like the functions, like how would we decide if this person wanted more music of the same artist or a different artist. But if we give it enough data, then we give it a lot of playlists where some people just make playlists and probably add album by album by album because that's how they listen. So there's going to be a lot of music of the same artist. So when that person puts a new song in a playlist, they're probably going to put a lot by the same artist. But then, like you say, some people just like to listen to wildly different music. So we're going to have a lot of playlists that diverge from the starting point. And we can watch like the arc, or if you almost think of it like a waveform of like the motion through like the space of all music, right? As this playlist moves, we can kind of predict like how the momentum of that's going to carry. So based on how you've started your playlist, like the algorithm, just the black box for you, it compensates for a lot of these things. Yeah, and that's where just getting hands-on with this stuff is key. It's like just kind of understanding what algorithms, what black boxes allow you to fuzz a lot of this. Like that's the beauty of so much of this, is we get to be so much more loose. Like we can just figure it out.
I know you were saying that a couple times, but I don't know what
Yeah. So I was saying, as you hear like algorithms and a lot of this jargon, like there are a lot of different kinds of algorithms. Like people in AI, especially engineers, love to talk all day about their jargony buzzwords and just talk at you with it, and just learning to kind of like compartmentalize all that stuff as their black boxes. Like you don't really know what's going on behind like vector selection tools and stuff, and like the math that's going on there. And that's where we are so much with the discussion around AI and machine intelligence right now, is we're talking about the underlying math and the really hard, dense part of this. That's very, very important, but we have a lot of people that are doing great work there. Scott?
In terms of black box, the way for me to understand it is, say when I was doing some product work, the engineer would be in charge of coming up with all the gearing mechanism. And I didn't need to know what those gears and linkages looked like, but they would tell me what the shape of that was. It was literally a black box. They would just be like, it's like this, and it needs to fit in what you're doing. That is how I like to think of black box.
So as a driver, you can think about your car as this intricate system of all the things that go into it, or black box the whole thing, and you push one button and it goes, and the other and it stops, right? So it's kind of just a logical way of like, I don't want to worry about that detail. All I need to know is the input and the output. So in this case,
Yeah,
good question, very good question. Yeah.
It's like I was, we were talking about different models using something, and I knew that the thing that they're using it for sounded a lot like part of speech tagging, which I've used in Markov models for, and it looked great.
Yeah.
And I was trying to explain to the Markov models, and I realized I had no idea, I have no idea how these work, and finally I just said, I have no idea how this works, but this problem we're doing looks a lot like part of speech tagging, and I know this, that I have Markov models work great with part of speech tagging, so that's why I want to try this.
Yeah, that's a perfect example. Like, I don't know how this works, and it doesn't matter. Like, it works. I mean, that's where a lot of the work that, as designers of this, we're doing, you know, the reality of it. Yeah. And it's don't learn the stuff that you don't need to know. Like, I'm not prescribing where you should stop learning. I'm saying like that this should be a decision that you make and kind of pick a chunk of this. It's a big thing to get into.
If it's all based on pure mathematical equations, is there any reason to fear it? I mean, is it not possible to trace it, how it learns something?
So is your question like figuring out how it learned a specific thing? So there's so much that goes into any type of prediction system that we can take a single prediction. Like we could take an input and an output and we could trace that back and figure out like what neuron, what connection, what fired it. And if we have the right type of system, if we tracked all this stuff, we could even drill back to like what in our training data, like what overlapped and caused this to happen. But understanding on a bigger level, like I'm gonna give this thing this input and this is gonna come out, like that's kind of like saying I'm gonna interact with this human and this is gonna happen. Like we can be really, really highly confident about what's gonna happen, but you know, there are outlier events. Strange things happen.
There's some of the new networks provided by Google have up to 340 million variables in their equations. They take as much as, I think it's something like 6 days on 500 computers in the cloud to train, which is equivalent to 6 cars. All the gasoline they ever use is how much heat is produced from these machines to train these models one time. So it's a $250,000 experiment and 6 vehicles to train one time.
How do they test it?
How do they test it? You can probably talk about that, but they have like, they test it every time they run it actually, on every single run. And they basically do it hundreds of thousands of times to train all these 340 million equations and variables. So it's like a huge magnitude, so you can't really go back and find your way through it and understand it, because there's just too much.
There's a lot of effort being put into this question and designing algorithms where we can create an output and then we can ask that algorithm, especially in natural language. Like we can talk to these algorithms really. So if you can give the algorithm input, get a linguistic output, and then go back and ask it why, like just like you would talk to a human, like why did you say that to me? Okay, like with this input, what would you say? So there's work being made there, but that's always going to be overhead on like the core functionality of that algorithm. Really great questions. Great answer over there, man. Did you have something else to add from earlier? You had your hand up.
No.
Where we at?
So you mentioned data from
Computing?
the wild. Next one? Yeah.
And we need a little data from the wild. So you made a really good point on training, and you were asking about testing. You're kind of talking about a fitness function. That's another bit of jargon that's good to know. A fitness function, he was talking about running like hundreds of thousands of passes through the thing. So what we do is we kind of just randomly initialize an algorithm. So we just like throw up a random state and then give it an input, and then we know what an output should be. So if we're gonna go back to the Spotify playlist, like we have a whole lot of playlists, we give it like some inputs on a playlist. If it gives us the next item that we knew was next in a good playlist, then we give it a reward. We say good job. And it goes forward, and then it goes backwards through the thing and writes it. So that's all you really need to know about training and backpropagation. So these are big words, but just know that the thing tries, and if it did a good job, it remembers it did a good job. It tries again, and if it didn't do a good job, we just don't reward it, and it forgets eventually. It's super simple, and it happens billions and billions of times, and all of this intelligence is kind of like an emergent property of these really simple decisions.
And for these buzzwords and these terms, we're going to share this PowerPoint deck with y'all. And the reason we're recording is like I said, posterity. I usually, after these discussions, I go home and I Google a lot of things.
We didn't need just like a Google list.
Yeah.
Yep.
Stephen, that what you're talking about just sounds like evolution and the survival function. Like the machine wants to survive.
Right, yeah.
So it learns what it gets rewarded to do. And then it's like, oh, that thing is not good for my survival, so I'm going to forget that.
Yeah, I mean, from the right philosophical standpoint, it is all survival of the algorithm, right? I mean, the thing does good, it gets to carry on. It's ascribing a bit of like personality to it, but yeah, dude,
I had a question. So we were talking about Spotify, maybe this applies that. So it sounds like there is kind of an out of the box or training. So training that happens before it's ever interacted with an actual individual user. And then are products that you're using AI then getting personalized training that then makes them distinctive to Adam or distinctive to me, or they just feed back into the general pool of, because that to me seems a much better Spotify if it, I don't know. I don't
So
know.
Spotify's not going through the effort to create, like, to train a custom algorithm
But we
to
could
pick
get
songs
there.
for you.
Right. But would we want to
I
get
don't
there?
think that they're kind of clustering users. What I would do in that case is like kind of like people generally, like clusters of people listen to similar music and have similar musical tastes. But I would cluster people and then create it. Like the next improvement would be kind of creating a custom model for each cluster of people.
And that's because of just data or cost?
It's
or
expensive
it's
to host
expensive.
models. Yeah. If like in a world where we didn't have the expense, like it'd be great to have a model for every person. Second Brain's approach that we think differentiates us much from the approach of the majors is like a lot of these major companies are trying to like create the algorithm that represents all of human, and we feel that that is like an inhuman thing. Like Google's translation algorithm it's like it's academic language. There's no way to go to Google Translate and like it know you from all that Google already knows about you. You know, I mean, it knows how you talk. It knows how you talk to other people. Like they could do this, right? We think just the customization, the personalization is what makes this human and what makes it, an augment to human ability versus a replacement. Hope that answers your question. Was there anything else in there?
No, I think I'm good for now.
So data from the wild, we need data.
Sorry, I think the part of what she was asking before was a little bit also with the ethics of things. And so where does that come into play with this?
Massively. Yeah, and that's a big part of this discussion. As designers, like what is our responsibility there, ethically?
I think it's
in that sense is getting as diverse and different set of input data as like this is correct. That way it's from just about every point of view of okay, this is what we want the model to go like, right? Because at some point there is a human decision of saying this is good. This is an example, right? So if you can get as many different kind of voices in that setting, I think that helps move toward the good ethics.
So that goes different than the Nielsen or only just 3 to 5 types of things, as we want to get much more diverse voices.
Yeah, I think a large sample size is definitely more recommended in this case.
Yep.
So you're equating, sorry.
Oh, sorry. Well, just the other part I wanted to say is because I'm sure everybody's like read in the last months and so on, where it's like all these autonomous vehicles. The input that's been training them on what they see is white males maybe or something, but it's not seeing a lot of diversity of skin color and things like that. Yeah, animals and so on. And so, that's part of the ethics question also, is really how careful is everybody watching what's
Yeah, that's the big question of our time, kind of. Is this intelligence going to be as biased as we are?
I
The
think
ways we are.
also not equating accuracy with ethics, right? Because the deep fakes, the better they get, the worse they are, right? Like accuracy isn't necessarily the good. There might be two separate questions.
And I think
Maybe not for safety, but maybe for deep fakes.
you're touching on something so important in the way that these algorithms can be biased. There's a prevailing line of thinking out there that because this is math or because they're algorithms, they can't be biased. And I mean, they are biased. That's it. Like the data that we show these things is our bias. So like it's deeply, deeply important to have everyone's voice in the room and to break that bias.
And I'd say on top of that too, data coming in from, I guess, kind of more ideal sources. So you talked about traffic, right? Right now we're training it based on human drivers, and humans get into a lot of accidents, right? We're not able to train it on a perfect simulation and have traffic move perfectly because we're trying to fit it into our existing world. I think an ideal setting would be we have separate highways just for self-driving cars, and then you get to start out on those versus trying to integrate it in with our garbage, because the input that we're putting in starting out is less than ideal.
There was one thing you touched on about the model and the algorithm being different. And I did want to say there are two distinct phases of work here. There's the training, which we kind of touched on this, and that's where you use the algorithm to create a model. And then there's inference, or putting the things into production and using them. And that's where we combine that model and the algorithm to give us answers. So two distinct phases of work here. So good intuition.
Yeah.
So what is NLP? We're not going to dive as deep into this. We're literally just going to say NLP, natural language processing. This is a Google rabbit hole that is really fun to go down. Computers, AI, applied AI, machine learning, and language.
And I mean, language is so at the core of what we are that language is just it's a really fun way to get into this. It's possible for everyone to bring a unique perspective on language, and words are really cheap computationally. Like, you can have a lot of words for the same file size as an image.
So we're going to get even more technical. Just thinking about everything that we've been discussing, in a way, even language, if you break it down to its comprising characters, it's a piece of data. If we think of machine learning, if we think of AI at large, if we think of applied AI, if we think of any of these applications of this type of technology, it comes down to data. A material that we as designers, when we're thinking about the manifestation of what's going on in this black box that is presented to a person at a touch point in a service or a process, if we think about the implications of what goes in and then we decide what comes out, we're really grappling with data. How do we use data, working with engineering teams and communicating with engineers and engineering teams and product teams, and using that to manifest or create an artifact that, because it is made of data, is ever changing and is dynamic. And the way that you get, I've learned from working with Steven and working with engineers on projects at work and side projects, that the way that you get your raw data, your data in the wild, the way that you get your material, and then as a designer, it is made usable, is by way of something that is called an Etl pipeline.
Anybody? ETL?
Extract, transform, load.
Got it. Yeah. Cool. Yes, nailed it. So when we move data around, as data scientists, we usually break that into 3 distinct tasks. Extract is where we get our data. As designers, that's probably going to come from a data engineer if you're working on a team. The more that you can do for yourself to be able to find data or grow data sets, digging around the internet, this is where it gets really fun, is just finding what kind of data you can find and what you can do with it. Just really any source of data, being able to bring new data into this world and then just kind of create more data out of that data, synthesizing data. Transform we're going to talk about in a minute. That's your main lever here. That's changing the data, and then load's just passing it on, loading it into the next system or in our case, into the training process to create a model. So, we're on Etl pipelines? Cool. Basically get data, change the data, and pass the data on to an algorithm. So extract, if it's, I don't know, if you're working with data engineers, then you'll probably get pretty clean files. You're probably going to get stuff that's kind of to a spec that you can work with and look at. A lot of times you're going to be working with like big, wild, raw data sets. So getting kind of good at what we can do to transform that data, what we can do to manipulate the data is really useful for us here.
And what's useful as a designer working with, if I were to work with someone like Steven, just understanding this process and the terminology, I can think, what form would I like to get to think about? I might not have to do the heavy lifting as a designer. Maybe I'm working with a data engineer. Maybe I'm working with an analyst. And it's communicating to them, what would I like my input, like my input from you, what would I like that to be?
And this is an opportunity as designers to do a lot of bias busting. We're talking about bias data sets and stuff. This is where, like, this is the place to run up the flag. If, like, I mean, data engineers that are working on pulling this stuff from systems are usually so focused on, like, the system and, like, the data that they're so removed from the human that it's deeply important that we have somebody who's really thinking about the human and the impact on all humans of what we're doing here. It's one of the reasons I think the transform steps are so important. Etl pipelines. So we kind of covered T pretty well, huh? You want to introduce this one?
Yeah, so to what Lisa had prompted us with earlier, what are some of the things that we need to think about as designers? What are some of these, when we are presented with this black box, how do we approach that? An interesting, is analogy the right word?
Maybe, I think so.
Maybe that's the right word. Stephen was telling me that when he talks about this with people that are looking to transition from more traditional types of development into this world, he thinks he'll break it down into two pretty functional structural aspects of programming: for loops and if statements. So if we think about what are the for loops and if statements of the engineers, what are our design analogs? As designers, when we're thinking about what it is that our engineering counterparts are doing, what are we doing? And this is the point where I don't have the answer. I'm curious what y'all come up with.
Yeah, like what are the vectors and pixels of data? You know, what's the grain that you can manipulate, right? Like what can we do to these things?
So we're pulling in the classic how might we, and again, this is we can approach this one of two ways. Curious what you guys would prefer. We can contemplate this a bit on our own. We could break into our quads again, try to come to a consensus and then speak to the group, or we could just have a discussion at large of when we're thinking about as a designer, when I'm working with my engineering counterparts, and I have access to these trained models and these sources of raw data transformed into something usable for me. How do I take that? How do I use that? How do I communicate with them so that I'm able to leverage that in a useful way, or in a way that helps me gain insight into what is happening in that black box? Is anyone really a discussion as a group, or is anyone really, really keen on sitting with this for a second, maybe speaking with smaller groups?
I like speaking with smaller groups.
Smaller groups?
Do that for a few minutes to sort of say some stuff out loud, all of us.
Yeah.
A chance to speak. And then
Yeah.
go back to the group.
Yeah, we just kind of dropped a knowledge bomb.
Yeah.
So it might be okay
Yeah, that's
with
a lot.
that settled.
Okay, thanks.
I wonder if it would help. So obviously all this know like recommendation algorithms, but I don't know if I know enough of like what. Yeah, to think of like how we use it. I'm like, I don't know what tools we use. You know, I've got a
It's a
tool
little like,
and it should.
and there's so many of those little things, which is what's causing this wild growth.
It's a lot to take in.
It's a lot to take in. I know. We tried hard
You guys
to
did
like
good.
bring this down.
No, you guys did our level, yes.
Y'all started to all of the But I think closing the gap between engineering and design is really
Start playing with it.
I guess I never really thought about it being kind of, I just thought it was, like, we give to us, we give to them, and they do blah, 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 et cetera, and so on, so.
Yeah,
Oh,
like
you're so
that.
wonderful.
So wonderful.
I know. I'm not embarrassed, but it's true. Yeah, okay.
Lob it over the wall.
Yeah, okay.
And it's so much more active than mine. It's crazy just how, like, push out something that's not even trained or functional on what you want it to do. It's just giving you an idea that it's capable once it gets enough data. And then you just give it to humans and like if things work out, it's almost like a cranking engine. It's like this starting process. Which I feel like is what we've been going through for the past like 3 years. Like all of people's services have really and they're starting to grow back up. But that's their big switch over to machine learning. Because you can only do so much in a lab. Eventually you kind of have to give it to people and then you find all the really corner cases. The way it manifested for us is we live in Louisiana and going home, Google Maps just really fell off in locations where they just don't have much. But there just comes a point in time where you have to make a decision.
I don't think I noticed any of that. Interesting. Just 3 years, huh? I did not know. I did not notice.
When did that switch happen?
It's been something they've been doing for like 3 to 5 years. It really started happening.
So there's kind of angles to look at, because like, you can try to say, okay, you have all this
But then you like translate, Google Translate just power this up.
Should we start going through the different things?
Probably. Are we trying to finish it on?
We should try.
Yeah.
Or at least get
I'm gonna just go like way faster than I was before, because we're getting to like, well, everybody's talking about it. Like, I don't know how much we're really gonna get into ETL.
Yeah. So now we're going to just go through the categories and the cluster.
I'm saying I think
This thing is what's like, they're just discussing design versions. So that it's like, that we could leave it,
He's talking.
We kind of need crunching each other head into
Who made the cake?
Andrew, he's Canadian.
Pointed it. Oh, it's a Canadian. Which one is Andrew?
He's next to Amelia.
That's cool.
He's next to
I'll bring a
Amelia.
cake next time. I've been making hand pies.
That'll be fun.
Oh, they're good.
I like pie.
Oh, yeah.
Right, do we want to do the audio then?
I don't think we give a shit.
We can just kind of like, hey, this is
Like a little treat.
do we want to kill this
Is there
slide?
any cake left?
What are we going to do with
Oh,
that?
yeah, cake's there. I think they're flipping.
Yeah.
Do you want me to still talk about clustering,
Yeah, I think we should.
translation, prediction, generation?
For a nice bagel with some cake.
I'll do close.
Was that one with designers?
We're going to tell you.
No. We should probably discuss for like, you want to do a few minutes? I think it's important to give people a chance to talk afterwards.
Hello.
I can also wrap this in like 5 or 10.
Hi, everyone. Hello. Cool. So, was that a good amount of time to sit with it for a little bit, vocalize it with the group? Who's feeling brave enough to share what their group thought? Cool. Perfect.
I struggled at the beginning with the question, how might we work with machine learning engineers to utilize data? We ended up talking a lot about how to communicate from one point of view to the other, and for me, it was a revelation that if I'm trying to figure out, if I'm trying to explain to an engineer so that they can maybe figure out what the algorithm needs to look like or what algorithm we need to pull, if I just put myself in the position of the machine and describe what I would do as a human to complete this task, it would allow that engineer to figure out, what parts of those are automated by the machine to what extent.
So it seems like a big breakthrough. You were thinking about how would you communicate what you want to them and how you would approach it to someone else
Yes.
who can go into their black box and make magic happen, find raw data in the world, and give you something useful that you can use to test an assumption you had.
Yes, yeah, and we also talked about use cases, sketching out like user flows, things like that. If then in the visual sense for me, especially, and for someone who's more used to programming, it's just very easy for them to perhaps just list them off real fast. Just visualizing.
Yeah, that's an interesting thought. How do you create a visual analog to what's going on behind the scenes that is digestible for someone like me, like you, who works as a designer who isn't a fluent programmer?
Yeah, I can't make a for. I mean, look, I read a for loop, so I can't make that. I don't know what that. What's a for loop? I was like, I need definitions now, but we got it together. We got that together.
Guilty good.
Yeah, no,
Figured
that's
it out.
Good one.
Correct.
I love personifying the problem.
Yeah.
Like stepping into the headspace of the problem and then describing like your experience there. Like, yeah, it's good design pattern.
We really grappled with this question as a whole because it really is more about how humans are going to communicate what we need from one another. And I think we kind of grappled with this idea of like, well, how is that really, how does that information really get transferred from one person to another, maybe? And we went around, had a couple of different conversations about asking the right question and also going back to designers maybe being involved in the process of understanding how that data gets extracted to begin with and being there on the very front end of something. And would that be useful and how complex is it? That was something that was kind of mentioned is like the transform process is also the most complex part of the process and that can be very probably draining to have to learn to do both.
And I guess to add to it, like the designer's role is to like ask, like raise those questions, what are those higher order questions? Because the data is to help us answer what those questions are, but making sure we're asking like the right questions in the first place. Because data, I think it's important to say like raw data, we have access to tomorrow. The world data is just like a representation of like what the world is like putting like what our mental models of the world is like, and really just questioning like useful insights like that is a designer role. What counts as useful insight and can data help us get there, which was a lot of what we're trying to say as well.
You touched on something about like needing designers at all phases. Was that right? That I heard? Yeah, I think, and that scale of the project too. Like ideally, we'd have somebody with an eye on design at every phase, especially like you said, the extract, because that's where we can introduce so much bias and break bias early.
So I had a question, if you don't mind, to just tie it back to kind of like the, this whole speculative futures, like, we think a lot about what data kind of, we think about what a lot of data is. It's like data up to like what the data is like really representation of the past and like up to like the present. And then futurism, we have like a whole way of thinking about like what are trends, and that's what data does. It will illuminate what trends are. And if we think about what artificial intelligence can do, it's to help make predictions based on that data. With all the technology, cost prediction is going down, and like based on trends, we know like if we project trends out into the future, it's like a probable future. The probable future doesn't necessarily mean it's a preferable future. So I mean that's more, I guess, more of a question than like a comment, but just kind of like trying to grapple with like what that divide or speculative is and what that means for like speculative design and like creating artifacts for like the future.
Yeah, it's interesting. Thinking about what could come, you look at what happened, and as a designer, something that I like to do is I present something knowing it might not be right, and it helps me to refine what I'm presenting. So I think kind of what you were grappling with or asking was, if we are doing something that is inherently speculative, inherently futures focused, inherently a forecast, less a prediction, more a forecast, but we're using something that is a static or time-based representation of the past, how do you marry the two?
Yeah, exactly. And it's just kind of like, would it almost bias us too much towards like the status quo orientation? If that is what data is. A lot of times it's the status quo. Like, if we're talking about the future, like maybe that's not what we prefer or what we want. We want something, we might want to imagine something that's different than based on like what the past is. Like tell us like what best prediction is one that is like similar to like yesterday.
Yeah, that's a big question.
And it's a massive design question. How do we be honest about that? Like, how do we deliver these things and the utility that they can provide, but also be honest about the uncertainty of them?
Be honest about what?
The uncertainty of these predictions. So we're talking about predicting the future, and there's just always outliers. Like, there's always an unexpected event, and that's just a function of this. Is we can't know what's coming based on what's coming forward.
But it's more along the lines of like the way data is constructed is that like, and with like AI, it would like, if we're trying to, I'm having a hard time like articulating this, but as designers and speculative design, like we're in the business of trying to create desirable futures, and sometimes to get to the desirable future, you need those like black swan events, you need those like wild cards that we haven't anticipated. But what data is that it tries to like capture like what the past is and like the current status quo of things that isn't necessarily like receptive to those black swan events. So
Yeah.
I guess the worry is that it will lead us to a path of just going towards the probable future, but the probable future might not be the preferable future. So like that's kind of like where I'm trying to like square the circle.
I think it's important that we don't like defend the status quo, like you said. Like, that's a great way to put it. Like, make sure we're not dragging ourselves right back to the regression to the mean, right back to the center.
Are you saying basically like if we become too reliant on like predictions, essentially like people will start to behave in a more formulaic way because they trust the predictions so much that they just kind of gravitate towards that?
That's one part of it.
It's self-fulfilling prophecy.
Yeah, that's one part. Yeah, that's one part of it. Is like that becomes a self-fulfilling. But it's just also just the way data is structured. It's very much about like capturing what is like an animal.
It's always one step behind on us.
Yeah.
Because it only has the data from, the last data point, which is right behind us.
Exactly.
It's always a step behind.
Exactly. It's essentially like it's going to help us understand trends, but trends are like one input into like creating like the future we want, but it's not the only input to create the future. I guess it's like the more.
But we also, as humans, don't have access to future data.
About that.
So,
Speak for yourself.
let's team up.
It's like that.
For the rest of the class.
No, but we can advocate for certain things though, as opposed to just going by what are the data points there, so.
And we can imagine something we haven't experienced yet.
Yeah.
It's like a philosophical question.
I think that's a really good question for like an entirely different, like the next event is like, let's all go have a beverage of our choosing, alcoholic or not, and sit and just like wrestle this thing to the ground. Feel free to incite that and start that. Whatever bar you want to go to, I'll probably tag along.
That's one of the big fears here. Are we expanding our horizons or limiting them?
So yeah, it's a question for you guys. If you're using data as an input and data is inherently focused on the past, how do you provoke the people you're working with to not just focus on the mean?
Yeah, and then extrapolating based on that past.
At the end of the day, the real world's a lot more complicated than the limited data we have.
I mean, that's
This is running in the real world, so it'll never be able to simulate everything and itself. Probably. So, the model will always be lower fidelity than the world around it. Unless we crack that. Was it?
all these scooters that we have out on the streets, right? They have a whole bunch of raw data. Let's just assume that every scooter rider has a phone and that is producing a whole bunch of data as it moves. If we want to make something useful out of it, I think as designers, this is something that we're talking about, is we have to understand what data is available. And not necessarily like, okay, we know that there are all these numbers and there are, we need to equate it to something. So maybe we know that there's speed, maybe we know that there's a direction. We have to understand kind of how the data is labeled so that we can make specific combinations of that and potentially make something new. So if we know that all of the bird riders at this time go this speed in this direction, can we make some sort of service for them, right? But we're not going to understand that if all we know is 1, 2, 3, 4, 5, 6, 7, it's just we have to kind of transform that data so it's human readable for us, so that we can create those formulas, so to speak. It wouldn't be the mathematical formulas, but it's just like, okay, let's just combine speed and distance or some sort of physical property or whatever.
Yeah. I think that's getting very much into like a design view of data.
Yeah, I think as complicated as this stuff it seems, like a lot of the basic tenets are still the same, right? It's like you still have to evaluate the user and like the knowledge gaps that they have so that you can provide the proper knowledge in the world that they need to be able to make decisions and achieve their goals and do whatever they need to do to succeed. So it's a lot about, like giving visibility into the scale of the data itself, but also then giving visibility into like what is possible with that data and what can be achieved.
Perhaps that helps address the issue you're trying to tackle. That as designers, we can see what is and what hasn't been, and we know where we want to be, then we can try and course correct if we're going in the wrong direction with design.
And that's a great part about the speculative futures aspect to bring it together is we can take, like, we can predict well if we know where we're going, giving it an endpoint and asking it to help us get there. Like, that's a beautiful way to think about using these algorithms. And as designers, should we step back from like trusting what the algorithm tells us and look more at like data up till now and then like an intentional place to go and then use these algorithms to draw paths to that place a little more. That might be a more speculative futures, kind of core approach to designing this stuff.
Yeah, I think it's a futures-focused mindset that could be applied to any number of traditional design disciplines of using what we have to pressure test what we want and seeing where we need. I like the term core. I think course correct was a really sharp choice of words. I like thinking about like how do we course correct based on what we know and based on what we forecast or assume might come, and how do we use what's in the real world to validate or invalidate that. And it's just adjacent little like changes and experiments and seeing is this working, is this not.
And how cool if we had a path of experiments and expected outcomes. And then when you don't hit one, look for another divergent path.
I was thinking, so we're talking about speculative design. It seems like context, like looking at a bigger context than we normally do when we do product design, which is usually very laser focused on, utility with helping people with scooters, avoid traffic or avoid, I don't know, bird droppings or something. It's a question for anyone. How do we bring AI and machine learning to that level, to like that systems view level? I don't know, it's an open question. I don't really have.
I've actually been contemplating this as conversations been happening and sort of lost my own mind, so I apologize if I missed anything. But I think having like an anthropological view of AI is probably the first and most important step because it's made for us, right? It's made for us as individuals. It's made for us in a group setting. So like me as an individual, you as an individual, we are free, but then the relationships between us are just like increasing complexity over time. And we may not be able to see those patterns, but using principles of like things that have already been discovered in the field of anthropology and sociology might be really useful to us in training AI for other
good answer. Do you want any to discuss any more of like the specifics of that? I missed the word. You said a specific train in a specific kind of model.
Agent-based?
Agent-based model. Okay, got you. Yeah, yeah.
Because we're speculative futures,
Mhm.
and, it's a handy, simple, yeah, right, no, kind of, when you really get into it, that you could, that we could use to, get a jump up on foresight before we actually, poke around and perhaps in an ad hoc way.
I think, yeah.
Try and develop, or, and it's a pet peeve of mine. Some people want to develop an algorithm, but in many respects, and I've heard others, be very adamant about wanting to drive an algorithm. That they're not naturally emergent all by themselves. And, there's a lot behind the curtains.
Yeah.
But I really appreciated, ma'am, I really appreciated your kicking us off with talking about the systems approach. And that I believe also ties into the comment about what anthropology, not only brings to the table, but, is able to, anthropology can design it.
Yeah, and I think if we don't take the time to humanize, like as the people building and creating these things, if we don't take the time to humanize them, then are they going to be made for humans? I think what you're hitting on, like putting yourself in the headspace of the algorithm is a key first step. And I like how human you guys are.
Have you ever heard of a company called DeepMind?
No.
So DeepMind's owned by Google, and they're probably at the front of all this stuff. They hire some of the best people, and they're working on a lot of this simulations and a lot of these agents. And that is very complicated, right? Like just to even have a few agents playing a game it's a super, super complicated task. When you're doing something like vision or text or something like that, it's a small, specific task. Very, very, very defined goals. I want to find a box of face on an image. That's your goal. When you're saying, hey, I want it to behave like a human in a game, you've got just way, 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 way more variables. Because we are really complicated. We do all kinds of interesting stuff. So when you maybe kind of look at it as a human, anthropomorphize it, I don't think we're even really close to that. The computer's just copying really basic things we're doing. It's not thinking like a human at all. It's just looking for patterns and in a very, very defined inputs.
Absolutely. And some of the national laboratories in the national security space are doing work with agent-based modeling. One of the things that I've always wondered about our predictive modeling, whenever you're dealing with probabilistic, we always have an error measure, but we take that error measure for granted. And I'll confess to, on more than one occasion, being really sassy and saying, screw the error measure. Let's have a stupidity variable if you really want to get accurate at this. Let's own that variable as opposed to just tossing it off and, and just
Failure
writing off whatever weirdness we get, as, oh, that's error. Well, it's become pointless. And so, anyway, sorry about
But to model the error, to model the system, huh?
But, at the end of the day, we're going to have to decide, do we want machine learning or do we want to simulate human learning by a machine? And those two are very, very different. And if we do the former, I'll probably never get my stupidity variable. It'll make me sad.
I'm making a stupidity variable. So it's going to exist somewhere.
That's my tantrum.
I like stupidity.
That was a very, 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 I'm glad you asked that question. And pose it in the way that you pose it in thinking about.
I'm sorry.
Oh, I'm glad you posed the question the way that you did in thinking about if we're looking at something in a more speculative manner, a more probabilistic manner, it's more of a forecast, it's not a prediction. how do you account for the randomness and the human error in that? How do you work with these teams who are working with very discrete ways of working and making it more human? But that was really interesting, and then you started bringing up the points of, is simulation a good avenue to explore ways for us to comprehend these things that we're working with? Is an agent-based system, which is somewhat representative of the world, agent-based world that we live in, a good way for us to, or a good avenue for us to explore something like this? You had a lot of, your question had a lot of really good questions in it.
You're gonna have to repeat.
Oh, sorry, I was saying
I'm
your
so
question.
sorry.
Your question.
I went out of the room and I fell out of a tree today. It's just been a bad day. I really
Thank you for coming out.
Yeah.
Oh, yeah, thank you for your presentation.
I was going to say, I think your question had a lot of really good questions in it.
And you're very kind. You're very kind. I come out of, most recently out of national security space, and I left government recently. And one of the things that I saw, is that a lot of basic research was done around predicting entities labeled malevolent actors. And malevolent actors. And what I saw was an attempt to predict them as rational actors. And it was big R rational, as in rational choice theory, which will get us somewhere. It can get us along the way, it can speed us along the way, but in order to capture the richness, all right, and in order to capture some of the drivers behind some battlefield tactics that would involve not the most rational thing, but the most unexpected thing in terms of resources, material, and personnel. And and at the end of the day, and I'm going to speak for my compatriots here, when we were entertaining this question, and I'll surrender the carpet in a moment. I don't want to monopolize any more time. But we read that and we were thinking about this conundrum for us to ponder up here. We were wondering why what seemed to be implicit here, that designers seem to have ownership over the theoretical or the behavioral or the hypothesis setting tasker for this imaginary team, and that the design and that the developers seem to have ownership over the means by which we would deploy the modeling. And I get team division of labor, but we were really sassy and towards the end, and we thought, well, what happens if we turn it around? As developers, Tom might be better word with our designers. And when we flipped it around, because we had no reason to believe that it couldn't be bidirectional here, we started to wonder, it's not an either or. It's got to be cross-functional. Because when you start to dig into the data, all right, a skilled statistician digging into the data will uncover more and more and more behavioral questions. And they'll start to refine it. And when you're tired, and when you're a very tired statistician, and really need a buddy, to post the obvious. It's right there, but you're really worrying about doing the post-estimation testing and all of that, depending on, I don't know, if you're doing something like a zero-inflated negative binomial or something like that, because your data's all jacked up. And you miss the obvious. That's a brilliant variable, and it's been staring at us all day and all night. And it has to be cross-functional. All right, so I'll stop with the hand waving and possibly with the entrance. Give back.
Yes. Plus. this conversation has started, like, I spend a lot of my time trying to drag developers into the design world. This is very much me trying to reach across a bit, so like I'm glad that you brought that up. Also, something that I hear running through your statement was the importance of modeling human error versus system error. Is that something you were touching on? Yeah, stupidity variable. Yeah, I love that. Like, it's so easy to, like you said, treat the humans as rational actors and discard irrational behavior as an error, or to conflate it with system error.
In multiple logic systems, whatever flavor of logic system, there is going to be some human being who's going to do something that's just pig ugly stupid.
Yeah.
A lot of the novel stuff, though, if you've heard about the game, the Chinese game Go, and a lot of the games that they're playing, the computers come up with, people don't know how to make it rational. They come up with these crazy strategies that are people who can't reverse engineer to figure out how they kind of were creative enough to come up with these things. So it's not, and a lot of the professors and things talk about this as intuition. Like it's not like a rational if then do this thing. It's like just a light bulb.
It's inflection. It's you know, the guy in the bathtub figuring out volume displacement. Wow, you know, I was just taking a bath and now I've made a scientific discovery. That was pure abduction. It wasn't deduction, it wasn't induction. It was that your line coming apart and then pulling back together, and we can't explain it, but we know it's real. So it's art. And you know, this is covered from,
Multiple. Yeah,
What you
there
think?
could be an intuition variable. But it sounds like, well, I was kind of going back to the systems, you know, anthropological, you know.
Can you speak up a little bit?
Oh, I'm kind of going back to the systems, taking a systems view and, you know, incorporating an anthropological perspective, I guess, into how you approach AI. And so I wondered if, like, I know the early stages are, I don't know how far it's progressed, like, of people getting together on ethics in AI and maybe standards and stuff like that. And that being, you know, a point at which you can infuse those aspects and that type of thinking.
Yeah, I'm seeing more and more discussion around ethics in AI and bringing diverse perspectives into just engineering, into development, into all of these worlds. But right now, so much of the algorithm design is locked up in just where traditional power is locked up in the old school ivory towers. You know, so I think it's deeply important as designers and to just get involved with call and bias where you see it. I mean, we still have just a massive running assumption for people that it's very convenient to assume that that bias doesn't exist from certain standpoints, you know. And we have a lot of people who are designing algorithms that are arguing, you know, very tooth and nail that like these things can't be biased, like that they are themselves a fair representation of the world because they're mathematical.
What's the thing too, that we're never gonna be, I mean, we're still struggling to even, like, remotely understand the thing that we're trying to predict, right?
Yeah.
All this comes down to really, the whole point is like, we don't even understand our own psychology and our own emotions. And you're talking about the stupidity factor, I would say, like, I think you can predict a lot of what people do. It isn't logical, but it is emotional. And I think, like, but we don't even understand what those emotions are. We don't understand the psychology of our own behavior. And so until we have a better understanding of that context and like know what it is we're actually trying to solve or predict, like there's always going to be like blind spots and
Yeah.
it's just the unknowable, and it's just not even possible really.
That's a huge question. What are we trying to solve or predict? Globally, all, you know.
The thing that I keep thinking is like, we're the computers that know the computers.
Yeah, we don't know
Like
what
we're,
we're doing.
yeah, like we're the computers that built the computers. And regardless of psychology, the smarter, the more intelligent AI gets, no matter which path we take, whether it's human learning or machine learning, at an advanced stage, it'll still encounter, not even like from a psychological perspective or like an internal emotional perspective, but it'll encounter, you know, the same kinds of sort of philosophical most intelligent, if it becomes as intelligent as we are, it will encounter the same things that cause us to make art, to make things that cause us to consider and wrestle with, pick up the problem and then put it down again because it's too large for us to understand. And we don't necessarily want to ignore it because it's important to us. But, you know, there's always a double-edged sword problem. We all understand what a double-edged sword problem is. And AI will also encounter that at its utmost intelligence. So not even grappling with the human component of that, but coming away from that, it's still going to be encountering nature and like the forces of nature and the things that we haven't been able to manage or contain yet.
There are fundamental inconsistencies to this game.
But perhaps it will give us a new perspective. Because if we remove, let's say we remove the humanity from that AI, that's a new species we can talk to. You talk to your dog, it's not going to help you with philosophy. But in artificial intelligence, this part of to communicate back, maybe we will solve some of these problems just because we have another perspective. At least get closer to it.
Our patterns of attention also distract us quite a bit, right? You guys have seen the gorilla man video where they're all passing the ball to one another, and there's a it asks you to count how many times the ball gets passed, and you totally miss a guy in a gorilla suit. It's like walking through this crowd of people passing the ball, and you know, it's like our RAM and our intuition is like our hard drive, right? So we have these sorts of subconscious things, but we only have so much processing power. Perhaps the reason why we can't fully grasp and therefore love art and music is because we can't see those patterns, we just don't have the processing power for it. And it's sort of like this wanting or something that we don't get. But perhaps AI could tell us exactly why humans like listening to Frank Sinatra or, all these beautiful pieces of artwork that we love in the museums. We can identify some principles, but if the rest kind of leaves us. I would love to know what an AI would think about something.
Like the great mirror, like what if we reflect ourselves in this thing? And all of our great philosophers, all of our great thinkers, we've all been human. Like you can't remove ego from that equation. But can we take ego out of human intelligence in the machine? And then what happens, you know? Yeah. There's a lot of really, really fun philosophical stuff to get into.
I think too, tonight's been a great example of we're posing questions that just pose more questions. And I think
we've achieved recursion.
We have, and it's like a great skill of a designer. Of like, I feel like on projects, I go in and I'm like, all right, cool, you have a thesis. Like, I'm just going to keep asking you more and more and more and more questions. And I'm going to set bounds of my questions, so like set bounds of what the problem space is that I'm going to keep questioning and poking at. I think in the interest of time, I think we have to wrap this discussion up here. But we had more to go through that we won't go through. We would love, Royal, we, Stephen, we'd love to continue conversations like this. Our meetup group, we meet once every other month because organizing events like this is a lot of work. But we have a Slack. This is the Austin chapter. There are chapters in a lot of cities if you find yourself somewhere else. We're on Twitter. On the meetup page, I'll share, we'll clean up this PowerPoint and share it and try and share some of our thoughts and some resources, and it'd be great to continue this conversation. In September,
yeah, so I will be running an event on ecological thinking with a couple of fun, I'm trying to center it around a board game that we can all sort of dive into, focusing on scenario planning, what futures will look like with things related to air quality, water, resources supply, traffic, a fun topic for Austin. Anyone who's written 935. So I as a former environmental scientist, I've wanted to bring ecological thinking into futurism with this group for a long time. So I'm excited around that. So I hope to see you all there.
It'll just be a different system. I think at the core of futures thinking or futures-oriented efforts, it's inherently a systems problem. So yeah, thanks for coming, everybody.